Hey everyone, welcome to the Intro to Lidar and ArcPro tutorial. This originally started as a workshop exercise for the MAGIP conference, but since that's been canceled, we've adapted this to be an online tutorial. So there's a text set of instructions and also this video tutorial to hopefully help you work through this at your own speed at your house or wherever you're working from now. But this exercise was originally developed, it's been through a few iterations, but originally was developed by Keith Weber at Idaho State, and then adapted by Nancy Glenn and Josh Enterkine at Boise State, and then again adapted by the Spatial Analysis Lab to its current form. And so the goal of this exercise is to get you familiar with ArcPro in general if you haven't used it much, and get you a little bit of an introduction to the LiDAR tools that are available in ArcPro, both for viewing LiDAR data and for processing. Okay, so now you should have the data downloaded. If not, you can go back to our website and download it from there. So I've downloaded mine already into this folder here in my documents. But when you download that zip file, it should come with a file that says Lidar Workshop Montana once you've unzipped it. If you go into that, we'll just go through the data that we're going to be working with for this exercise. So the first folder here, called Classified Point Cloud Data, if you open that, that contains all of the files, last files that contain the point clouds for the LiDAR data. So this is what we downloaded from the data provider, and this is the form the data came in. If you go to the imagery folder, there will be a NAPE 2017 image in there. These next two, import log and index, we don't really need to worry about. Those are created by ArcPro when you start a new project, and we won't have any reason to go in these. This LiDAR tile index, if you open that one, there's two different shape files. One is a full index of tiles from the project area. So the DNRC's Water Resources are the ones that collected all of this data, and they collected it for the entirety of Valley County. And so that shapefile represents all of the tiles for the whole county, while this other one, called Project Tiles, just represents the area that we're interested in or that we're going to use for this exercise, so a smaller subset. This LiDAR Workshop geodatabase, that's going to be a blank geodatabase that you can use to save things as we go through the exercise. And this last one here, vendor products. A lot of times when you download LiDAR data, it'll come with a few other files, maybe some raster products or shape files. And so in here, I have two rasters. The first is a HFDEM or hydroflattened DEM of the area, basically a bare earth model. And the second is an intensity image of the project area. So we'll get back to what these actually look like later, but just wanted to give you a feel for what we have in the data folder here. Here's the set of instructions that hopefully you were able to download from the website, but if not, you can click on them here. And then this LiDAR Workshop Montana ArcPro file, this ArcGIS project file, that's a project that was created for you, ready to go with what we need to get started. Okay, so let's go ahead and open up this LiDAR Workshop Montana Arc project file. Double click on that. We'll open up an ArcPro document that's already been set up. And so once we get in here, we can take a look at what layers are already in the document for us. So over here in your table of contents, we have the project tiles, we have the tile index from the DNRC, so the full county tile index, and then we have a NAPE 2017 image. We also have this topographic base layer. It's the automatic base map that ArcPro will load in anytime you start a new map project. And so let's go ahead and zoom in first to our project tiles. So if you right click on project tiles, go to zoom to layer, and that'll take us into where this subset of the LiDAR data is that we're going to be working with. If you zoom out a little bit, you can see it's just west of St. Mary, Montana, which is north of Glasgow. And so the first thing we want to do is open up the attribute table for the project tiles. So right click, attribute table. We can see there's not many fields in here, but the one I wanted to draw your attention to is this tile ID. So each one of these squares in the tile index has its own ID, and that's how the point cloud data, the LiDAR data, is downloaded, is by each one of these tiles. So you download those individual tiles worth of data. And if you're following along on the text version right now, there's a couple questions if you want to take a look at those and try to answer. There's also an optional exercise on there using the SQL query builder in ArcPro. A lot of you, that might be a pretty familiar exercise and not necessary, but the interface is a little bit different in ArcPro. So if you are new to Pro and you're interested in getting used to it a little bit more, I would suggest going through that exercise and just testing out how the new SQL builder works. It's very similar, but the interface is a little bit different. So the next thing we're going to work on is creating a last data set. So to do that, we need to have our catalog pane open. Most of the time, it will probably already be docked over here on the side for you, but if it's not, you can go up to View and click on Catalog Pane, and that'll open it up. ArcPro is convenient in that it automatically will connect your folder for where your current project is, rather than you having to do it manually. So if you hit the drop down here next to folders, you should see our LiDAR Workshop Montana folder right there. If you don't, make sure that you have that Arc project file in the same folder as all of the data underneath this LiDAR Workshop Montana folder. So if you hit that drop down here, you'll see the same files and folders that we just went through in File Explorer. You have the point clouds, the imagery, the index, the vendor products. And so to create a new last data set, what we'll do is we'll right click on the LiDAR Workshop Montana folder, go to New, go to Last Data Set, and then that'll open this, or open up a new last data set down here. And if you go ahead and change the name of that, let's rename it St. Mary LiDAR, and hit enter. Took a second there, but so it's now we have an empty last data set. All this data set is a way to direct Arc's attention to the LiDAR folder files that we have in this folder. So really there's no data in here right now. It's just a pointer that will tell Arc where to look for the LiDAR data that we downloaded. So if you right click on the St. Marie LiDAR that we just created, the last data set, go down to Properties, and then you'll have a bunch of options here, but for now we'll just worry about going to Last Files. There's two different ways you can specify where your last data set should look for data. You can either add individual files or you can add folders. In our case, we have all of the last files in one folder, so we can choose this option. Then you'll want to go and navigate to our LiDAR Workshop Montana again, classified point cloud data. You don't want to double click on that. You just want to stay highlighted on it. So single click and then hit OK. And you'll see it'll load up all of the last files into this menu. So now our last data set contains all of these files here. And I would suggest taking a minute and just poking around on this menu. Go through the different tabs. You can even go over here to details next to each file and look at the file in more detail and get some information about point cloud size, the coordinate system. Here it looks like they're using some kind of custom system in feet for Montana. And if there's no information popping up here, you may need to hit this calculate statistics. But in my case, I have the information. There's also additional tabs here, classification codes, extent, returns, things we'll talk about a little more later. But I would take a second and just look around on this menu. You can even go back to general and look at some of the information here. And if you're following along on the text document, there's a couple questions pertaining to this menu. So once you've had some time to look through this menu a bit, you can go ahead and hit OK. And the next thing we'll do is add this last data set to our map. So if you go back over here to the catalog window, grab it and drop it out here in the map. Then you'll probably want to go and drag it to the top of our table of contents. And you'll see it just changed on my map here, but when you add a last data set to an ArcPro document, it will automatically highlight the outline of your tiles in red for you. So if we turn off these other tile layers, you'll see that our extent of our last files is still highlighted. Now that we've added it, we'll want to do some things to adjust the appearance. As you can see right now, we're not seeing any points because we're zoomed out farther than the display extent. I've already changed mine up here, but if you go to the last data set layer portion of your ribbon, go to the appearance tab, and there's three options in the point thinning section. So full resolution, I've changed mine from auto to 1 to 1000. This just means that once you zoom in closer than 1 to 1000, then it will show all of the points in the point cloud rather than just a subset. As you zoom out, it'll just show a subset of points so that Arc has an easier time drawing the file for you. This display limit, you can set it to control the maximum number of points that will be displayed at one time. I've changed mine to 850,000. That's about a third of the total points that are in each point cloud, and I think that's a pretty good rule of thumb. And then this density slider, you can click on it and adjust how thin you want the point cloud to be. It just means it will, it's not changing the file at all, it's just displaying a smaller or larger percentage of the points in the file. So it's generally a good idea to take this down a little bit. You don't need to see the maximum number of points at all scales. So once you've done that, you can zoom in a little bit, and you'll need to probably get close enough, maybe under 1 to 5,000, to start seeing your points show up. And so here's our point cloud. You can pan around and see some of the different areas in your image. After you've panned around for a little bit, you could zoom into some other areas, but zoom in closer than 1 to 1000, and you'll be able to see how that full resolution scale is applied. Once we get the scale underneath 1 to 1000, then you can see it draws all of the points in the file, whereas once you zoom back out above 1000, you're only getting a subset just to make the drawing faster. So that's how that full resolution parameter that we adjusted up here is applied. Another useful thing when you first load in your point cloud is to make use of this filters group on your ribbon. So under last points, you can hit the drop-down menu here, and most LiDAR data will come with a few things classified already. In our case, we had some ground points classified. And so you can toggle between different visualizations. So you could choose to only show the ground points. Right now we're showing all points. So if you click on this, the display will change and it will only show points that are classified as ground. Similarly, if you go and click on non-ground, this will show anything that's not classified as ground and classified as something else. This doesn't mean that these points are classified as anything. They could be unclassified or never classified or unassigned, but it just shows everything that's not currently classified as ground. So you can pan around, play with these different filters. I'm going to switch mine back to all points. And then I'm going to show you one more thing while we're here. If you, instead of clicking on the drop down, if you actually click on this last points icon, it will pull up a different properties menu. And this will allow you to see the current classification of the point cloud that you've downloaded. In our case, you can see we have 3 classes: unassigned, ground, and low noise are our 3. And you can do the same thing here that you were doing with that drop-down menu. You can check or uncheck different boxes. If you don't want to show all, you can choose to just show the unassigned or the noise or the ground points, just as you were previously. So let's go ahead and hit OK there. If you're following along on the document, there are a couple questions about the ground and non-ground points if you are interested in taking a look at those. I'm going to go ahead and move on and talk about one more product that typically you may get with your LiDAR point cloud. It's called an intensity image. And so that'll typically be a raster product that will show the intensity of the returns across your study area. And so if we want to add that image, it could help with some interpretation of just seeing how these point clouds are built. So if you go back to your catalog pane, under your folders, LiDAR Workshop Montana, if you click on vendor products, hit that arrow, and then there's one called St. Mary INT. Let's drag that out into the map and right click on it and zoom to layer so we can see the full extent. You also might want to drag this below your point cloud so that when we zoom in you can see the imagery underneath. Having some technical difficulties here. We'll be back up in a second. There it goes. And so with the intensity image displayed below your point cloud, you can zoom in and check out different areas to see what kind of, how the intensity is matching the point cloud itself. But what is perhaps more useful is to turn off your point cloud and just have on the intensity image and the nape. With the intensity image highlighted, you may want to go up here to stretch. I like to adjust mine to none in this case, just so that it's not so high contrast and I can see a little bit more of what's going on. But the next thing you want to do with the intensity image highlighted is click on the swipe, and that will allow you to swipe away the intensity image to see the aerial imagery underneath. And using this, you could zoom into different areas of the map, swipe away the intensity image, and try to determine how different cover types are producing different types of intensities. And there's a couple questions, or a question pertaining to that on the document. So pan around a little bit, swipe away that intensity image, and once you're satisfied and have answered those questions, you can go ahead and save your document. And we'll move on to the next section, which is converting our last files into some raster data and products that we could use. Now we'll move into the next section on converting your last files into raster data. So this is part 3 on the text document. And there'll be a few steps we'll go through prior to actually making a raster data set out of our last files. But the first thing we'll look at here is we'll go ahead and open the properties for the last data set once again. So you need to do this from the catalog pane and not from the table of contents. We'll go over here to catalog, go to the last data set, and go to properties. Now if you click the statistics tab, and maybe you've already seen this, but again, this is just showing the classification codes in our current last data set. So we have unassigned, we have ground points, and we have noise. And it'll give you some information about each, so the number of points in each classification code and the percentage and so on. So you can go ahead and click OK, and we'll visualize our last data set by those classification codes. So let's turn off the intensity image if it's still on, turn back on your last data set. I'm going to go ahead and zoom to that layer. With that highlighted, you can go up to symbology and go to class. Right now it's probably displayed by elevation, so we'll click on class. Let's hit the drop down menu and see. I'll do it again here. And you can close this symbology pane if it automatically opens up. So now you'll see over here on the left in our table of contents our last data sets being displayed by the classification codes. Again, we'll need to zoom in order to, and I'm going to turn off the swipe. So if you go to the map tab and hit explore, that'll let you go back to your panning. Go ahead and zoom in until you see the points. Again, you'll need to get relatively close. They might be hard to see with the imagery underneath, and you can feel free to click on any of these and modify the colors. I'm going to leave mine as is for right now. And you can see right now we have these brown points are our ground points. The unassigned are showing up in this gray color, and then mixed in are some red points you can see that have been classified as noise. You may want to zoom in or check out the area over here, the residential area that has a little bit more going on. And so you can zoom in there and see, although maybe these buildings are still unclassified, you can see the difference in the point cloud over here a little bit better in terms of what's been classified as ground and what hasn't. So one of the things that you may want to do with the last data set is you may want to reclassify your point cloud. It's not always necessary. If you're given a data set that's been classified and you're satisfied with it, you can obviously leave it as it is. But just in case you need to, let's go through the steps here. So we'll be using the automated geoprocessing classification. So to do that, you'll have your last data set highlighted. We'll go over here to classification, click on automated classification, and choose the classify ground option. And before you do that, you'll want to make sure under your appearance that you're currently displaying all points. If you were just displaying the ground points, this tool or this process wouldn't work the way it's supposed to. So make sure you're displaying all points, classification, automated classification, and classify ground. So now a tool will open in the geoprocessing window. It'll already be filled out for you in terms of the input data set that you had highlighted. For the ground detection method, there's 3 options. A standard classification is typically a good choice in a mountainous region. somewhere that has a lot of topography, and somewhere that's relatively flat, like the plains, the eastern plains in Montana, where we're working, you could get away with this conservative classification. So we'll go ahead and choose that. This option here, and if you hover over this, it'll give you information about each part of the tool. But this option will allow you to reuse what's existing as ground, so what has already been classified as ground. During this classification process, none of those points will be reclassified. If you leave that unchecked, it will reclassify your entire point cloud. So let's, just for this purpose, say that we're satisfied with our points that have already been classified as ground. So we'll leave them as is, so we'll put a check in this box. We want to compute statistics. We're not going to do anything with the DEM resolution right now. And a good thing to note before you run this is that this is actually changing the data. So this is not creating any new files. This is actually going into the original last files that you downloaded once you unzip them, and it's changing the classification in there. So this is a permanent change to that classification. So just as a good rule of thumb, you should always keep a backup copy of the original files somewhere, even if that's in just the zip folder that you downloaded. Just make sure you have the original files, because if you're reclassifying these and the classification doesn't look good, you're gonna have a really hard time getting back to what the original classification was. So just a side note, but good thing to note. The processing extent, if you leave it as default, it will process the entire image, but there are other options in there. Say you had a really dense point cloud and you wanted to test on just a smaller area, you could go to current display or the display of another layer in your map. But we'll leave it as default for now. And let's go ahead and hit run. This will take a few minutes. So mine's just finished, and you may not notice huge changes, but if you zoom in, you may be able to find some areas where some of the unassigned points have been reclassified as ground. You can also go back and change your appearance, so you're just looking at the new ground points, and maybe on a larger scale you might be able to see some differences, that there might be more points now classified as ground instead of some of the other things. The other thing, if you were keeping track when we looked at the statistics the first time, you'd be able to go back to the properties of the last data set, and under the statistics tab, check out the number of points and the percentages for these different categories. And after reclassifying, you may notice some change in the number of points in the ground or the unassigned. All right, now I want to move into quickly covering another way you can classify a point cloud in ArcPro, and that's using the interactive or the manual classification tools. All this means is that you'll select individual points or groups of points and manually alter the class of those. So this type of editing is obviously not very practical over a large area, or if you have a very large point cloud, you're not going to go through and manually classify everything, but it can be useful on small projects. It could also be a good way to adjust or fine-tune some portions of a point cloud that were classified using automated methods like what we discussed earlier. Please note there are some issues with early versions of ArcPro using these interactive classification tools. So if you have an earlier version of ArcPro and you're experiencing some issues, it might be a good idea to just skip ahead and pick back up in the next section of creating the bare earth surface model. So in this example, we'll manually classify just one tree, a single tree canopy. And there's 3 possible classes that you can put vegetation into. There's low, medium, and high vegetation. And these height ranges are predefined in ArcPro. So mine's already up over here in the geoprocessing window, but to view those quickly, you can go to classification, automated classification, and classify by height, and it'll pop up that same window over here. And so you can see in the height classification section here the 3 codes. So 3 is low, 4 is medium, 5 is high, and then the height over here to the right of them represents the maximum height in that class. So low vegetation right now is just going up to 5 feet. Medium vegetation is currently from 5 to 25 feet, and high vegetation is from 25 feet to 50 feet. And so this would be where you could go through and adjust these ranges in your classification if you were doing an automated classification. So let's go back to the working on the interactive or the manual classification. In order to do that, we'll zoom in over here to the residential area where most of the higher vegetation is going to be. And so zoom in until you can start seeing your point cloud, and make sure that only the point cloud and the nape imagery are on in your table of contents. You may want to, with this last data set highlighted, go up to appearance. You can do a couple of things. You could bump up the transparency slider so that you could see the imagery underneath. You could also use the swipe tool to swipe away the point cloud, or you could just simply toggle this on and off if that works best for you. But just zoom in until you can identify a single tree. I'm going to use this one right here, and I'll just toggle this off quickly so I can kind of get an idea of where the canopy is. And you may notice that a lot of some portions of this tree have been classified as ground. And some of this could be due to some georegistration errors between the point cloud and the imagery. But let's move ahead and go ahead and do this manual classification. So you will have your last data set highlighted. Go over here to classification and hit this select option. And that'll create a drop-down menu, and you'll select polygon. And so I'm going to just toggle this off, get an idea of where that canopy is, and go ahead and start clicking to outline this tree canopy. And once you get to the end of your shape, just go ahead and double click, and you can see that'll select the points that I've surrounded. Now to change that classification code, you can go in here to this classification dropdown. It's probably already on no change, but you'll want to select your corresponding vegetation class that you want to put it in. I'm going to go ahead and put this into the high vegetation class, and once you've selected a class, hit apply changes, and you'll see those points actually drop out from the point cloud. They're still in there, they're just not being displayed right now because we don't have that class displayed. So to get them back, go to appearance and click on symbology and class, and it will open up the symbology pane on the right. If you go to more and go to add values, that will allow you to select additional classes to put into the visualization of these points. So since I identified mine as high vegetation, I'm going to click on high vegetation, click on OK. So do the same for whatever class you put yours in, and you'll see those points will come back. And the legend will also show the class that you've added. So that's a quick run through of how to use this manual classification. Again, you can do that all over and for different areas, but not very efficient on a large scale. But this is just to give you an idea of how you can go in and manually tweak these classifications. You don't have to just rely on the automated classification. There are also some bugs that have been reported where these selected returns will not display properly. So if you select out this tree canopy and you're having trouble getting it to display again, a couple things you could try is to just save your project, close it, and reopen. Sometimes that'll solve the problem. The other thing you could do is remove the last data set and then re-add it. So right click remove, and then once you've removed it, go back in here to your catalog and refind it and add it back to the map. Once you do that, you will have to readjust the symbology to get it back to the classification symbology, but that's another thing you could try to get those points to show up if you're having problems. We are almost ready to move into making the bare earth surface model, but just before we do that, I wanted to touch on break lines really quickly. These are abrupt changes in the landscape, so it could be things like a cliff, a riverbank, an elevated roadbed, and sometimes LiDAR products will provide you with a layer that identifies these break lines on the landscape. And you could use that in your analysis. You could, under the classification, or excuse me, the data, appearance actually, under the filters here, there's a surface constraints, and that's where you could incorporate those break lines and basically inform Arc that your point cloud is going to have these abrupt changes, and that'll help correct for some anomalies in elevation or height across the landscape. Unfortunately, we don't have a break lines file for this area, but I wanted to touch on them anyway. And if you have the text instructions document downloaded, there are steps on how to make use of a break lines file if you do come across one in a future project. So take a look at those, or if you have a project in mind and you have those and are wondering how to use them, those instructions will give you a good idea. Now we're ready to create a bare earth surface model for our study area. So the way to do that, first you want to make sure that your last data set is highlighted in the table of contents, and then be sure that you're only displaying the classified ground points. And remember, to do that you can go up here to appearance, the filters group, hit the drop down, and go from all points. If it's on all points, make sure you hit ground there. And then from the data tab, we'll go all the way over here to the left to the management group and hit export, and then raster. And that's going to pop open a geoprocessing window. You'll see your last data set's already been put in for the input. The output raster, let's go ahead and rename that, and by default this is going to try to put things into the geo database that's associated with this ArcPro project, which you don't want for the raster. So let's hit the folder icon, and it'll probably start on this screen here. You'll navigate to your folders, Lidar Workshop Montana, and then under here I've gone ahead and created a new folder called Rasters. You can do that using new item folder, name it Rasters or however you'd like to name it, and then in here I've already run this tool, but you would name it Bare Earth, and you'll need to put the file extension, so we'll do a TIFF file, .tiff, and then you would hit save. Again, I've already done this, so I'm just gonna go ahead and skip that part, but make sure you rename it here and move it outside of your geo database. Then for the value field, we're gonna just go ahead and leave it as elevation. The interpolation type, we're also gonna leave the defaults here of binning, average, and linear, but I do want you to take note of this section. In other projects you may need to adjust these parameters. So for instance, if you're trying to incorporate break lines like we talked about previously, you'll need to adjust the interpolation type from binning to triangulation to incorporate those effectively. But for our purposes today, we'll just keep this, all the defaults here. The output data type, floating point, is fine. Sampling type, cell size, is fine. But we are going to adjust the sampling value here. So this is giving you basically the spatial resolution of the raster that you're going to produce. In this case, its default setting is at 10. In our case, it's feet. That's not going to quite exploit the density of the point cloud that we have, so we can adjust this down lower, and we'll do 3.28 feet. So roughly the bare earth model that we'll create will be roughly 1 meter. And the z factor we can leave as 1. So once you've adjusted the parameters, you can go ahead and hit run, and this should be pretty quick. I've already done this, so I'm just going to pan back out to the map and go ahead and switch it on over in my table of contents. And there's what your result should look like, something like this. You can adjust the symbology if you feel like it, but at this point the white colors are showing the higher elevations, the dark is the lower elevation. And you can kind of check, I would zoom back into this neighborhood, and you should confirm over here that you're not seeing any of those buildings. You can flip this off if you want to and go back to the original point cloud or the NAPE image. But in your bare earth model, you shouldn't be picking up any of those buildings. You might see some of the roads versus the lots. There's some difference in elevation there, but you shouldn't be picking up any buildings, and you'll know that it worked correctly. In this part of the exercise, we're going to use our point cloud to create 3 vector-based terrain derivatives: contour, slope, and aspect. To create these, we're going to go to the Data tab, and quickly just make sure under your appearance and last points under the filter that you're only showing the ground points. So we'll go back to the Data tab, we'll go to Surface Derivatives, and we're going to select the contour option to start with. Now over here in the Geoprocessing window, we're going to input our last data set. The feature class, the output feature class, is going to by default be written into the geodatabase, and we'll go ahead and let it save it there. That's fine in this case, and we'll rename this contour 525 to reflect the intervals we're going to use. And then in the interval section here, we're going to set this to 5 feet. So these are in units of the coordinate system that we're in this case is feet. So we'll do 5 feet for the interval, and then down here for the index interval, we'll set this to 25. All this means is that every 5th contour is going to have another field that labels it as an index, so that once you produce the contours, you can symbolize those index fields differently to help with interpretation, as you've probably seen on USGS topo maps with a darker line every 4th or 5th contour to help with visualization. So once those parameters are in place, we're all set. Before we hit run, I just want to note that a lot of times LiDAR data will be in units of meters, so if you're hoping to get contours in units of feet, you're going to have to do a little bit of math to convert those correctly, but in our case we're in feet, so we're good to go. So let's hit run, and the tool will run for just a second. And once that finishes, we'll take a look at them. All right, there it goes. So now we can zoom in on this contour layer we just created and take a look. And you might notice as you're panning around and zooming in that you might want to turn off the point cloud. There's a lot of areas that look similar to this, very jagged. There'll be a lot of these small closed off loops, so these contours don't come out very clean. That's actually a product of the point cloud itself. So we have a ton of points really close together horizontally that all vary slightly in elevation. There's going to be a small amount of vertical error within these points. Even points that are close together might have slight differences in elevation, and that's what's causing these kind of jagged and messy looking contours. This same issue will arise when you create slope and aspect derivatives. So something that you might want to do is thin the point cloud, and so basically just resample this dense point cloud depending on what level of detail you're looking for. But you could thin the point cloud and resample it based on a certain distance and clean up some of these noisy contours and other derivatives. So this is optional. It's up to you if you want to or not, but I'm going to go ahead and go through the process and just demonstrate it. And this will create a new last data set. So in order to thin your point cloud, you'll go over here to Geoprocessing. You might have to hit the back button to get back to the search. And you'll type thin last in the search bar and select this first option here. So here we'll put in our last data set. For the target folder, you can navigate to your project folder, Lidar Workshop Montana, and you can just put it in that base folder there. Next, you'll name the last data set. And let's name it thinned last. You can change this thinning dimension to 2 dimensions and change the target XY resolution. I've been going with 10 feet. For the point selection method, this is going to determine within that 10-foot window that we just specified, 10-foot by 10-foot window, what point it should select to keep. I would go with closest to average height. And then this output file name suffix is referring to, this is actually going to rewrite all of those last files and create new last files from the originals that are thinned out. And so this will name them with the same convention, but we'll add this suffix to the end of it. So we can just keep it as is. And we'll go ahead and hit run. And this shouldn't take too long. And there it goes. And you can see over here on the left that it automatically added it to the map. We can go back and change the appearance, use the symbology, and go to class to get it looking like our other point cloud did. And just quickly, if you want, you can zoom in under 1 to 1000. You can see how much less dense that thinned out point cloud is than the original if you turn your old one on and toggle the new thinned last data set off. So I'm going to go through the process and just recreate those contours we just did. Or actually, I've already done that. And so if you're interested in comparing the two, you could go through that same process again, go back to the data tab, surface derivatives, contour, and this time, instead of using the original last data set, use the thin last data set and input the same parameters, the 5 and the 25. So I've already done that. I have it over here, and I will go ahead and turn that on so we can compare the two. I'm going to turn off my point cloud. Let's turn this one off here. Just quickly change the symbology of this one. So it's something that stands out a little bit better. Let's do this green color. Hit apply. So now you can see on this, using the thinned last data set compared to the original, you have much less messy contours. And like I said, the same will be true when you're creating slope and aspect products. So I would take some time now on your own to go ahead and create slope and aspect derivatives. So depending on whether or not you thinned out your point cloud, you'll either highlight the thinned last data set or the original. With that highlighted, just to remind you, go back to Data tab, and then under Surface Derivatives, you can open up either aspect or slope. And these are self-explanatory: input, output, and hit run. I would recommend if you're not using a thinned data set at this point, the processing will be pretty slow to do the entire point cloud, the original point cloud. I would recommend going to this Environments tab, and under the Extent section, I would change this extent so you're not processing the entire area. If you zoom in to an area of interest, subset of the whole data set, say just this corner even, maybe at a scale of around 1 to 1,000, in the Environments tab, you can change this extent to Current Display Extent, and it will just run the tool for this subset. And that's a good way to go if you haven't thinned out the last data set at this point, just because the processing will take quite a while, and then the drawing of the layer will also take a while. So to speed things up, it might be a good idea to just do a subset. If you did thin out your point cloud, just go ahead and run those tools on the thinned data set. And I'll go ahead and just switch mine on quickly for you. I did use the thinned data set for aspect and slope. So here is the image of aspect, or the vector of aspect, I should say. And it's still quite a bit messy, but much less so than if you use the entire or the original point cloud. So there's aspect, and I'll turn on the slope now. Take a second to draw, but there you can see the slope. And you can expand both of these, obviously, to see the legend, see what you're working with. You'll notice there's a lot of high slopes over here corresponding to the roofs of the building or the edges of the buildings. But go ahead and create those layers either with the thinned last data set or the subset of the full data set, and take a second to explore them on your own. For our last exercise, we'll compare our results to some data that we received from the vendor. So like we've been talking about, sometimes you will acquire some LiDAR point clouds that also come with auxiliary data sets, like the intensity image we looked at, or even a bare earth model like we created. So since we created our own bare earth model, we also had one from the vendor. We will compare the two to see how they line up. So to do this, we'll go over to the catalog pane, go to folders, LiDAR workshop, and remember that vendor products folder that we looked at the very beginning has two products in it, the intensity image and also this hydro flattened DEM, which is also a bare earth model. So we'll drag that out into the map. And you'll see it pop up in the table of contents, and hopefully it looks pretty similar to that bare earth model that you generated. We'll go ahead and turn on the bare earth model underneath. And if you're interested, you can go up to the Appearance tab and swipe away the DEM. And like you can see on my map, there's almost no discernible difference. I'm sure if we got in here close enough, we might be able to find some subtle differences. But overall, they should look pretty similar. And so the next thing we'll do is we'll actually use some Raster Math to compare the two on a pixel level. So to open up that tool, we'll go to Geoprocessing. Whoops. Close that. Geoprocessing. We'll type in Raster Calculator over here, and you'll see it pops up. Both of these are the same tool, so either one is fine. And once that tool opens up, we are going to create an expression to subtract these two layers from each other. So we'll start with our raster. Double click on the minus, and double click on the bare earth model that we received from the vendor. For your output raster, you can go ahead and hit this folder, and we'll browse to a different location. I would put it in the rasters folder if you made one. If not, feel free to save it anywhere other than inside of this geo database, because we're going to save it as a TIFF file again. So I'm going to save mine in rasters. I'm going to call it elev diff.tiff. Don't forget to put the extension on there. Hit save. You'll see it pops up over here, and then we're ready to run. And there you go. So there's our difference image, basically subtracting our surface model from the vendor's surface model. And you can see in the legend over here the ranges of values in this elevation difference layer. It does look quite pixelated, and that's because of the resolution of the our bare earth layer. You can kind of see those tiny little pixels in there. But you can also adjust the stretch type with this highlighted to try to make it look a little bit smoother. Min-max makes it look quite a bit smoother. But for now, I'm just going to leave mine. This is the legend is the more important part rather than the visual. So you can take a look at that legend. If you're on the text document, I think there are a couple questions that pertain to this portion about what this layer is and how to interpret it. So pan around and check it out, see where the elevation was consistent between our surface layer and the vendors, and you can also go into the properties here and examine the resolution, the spatial resolution of each, and see if that had any impact on some of the differences that we're seeing. But once you're finished answering those questions and checking out this layer, you can save your project. And this is the final exercise of the tutorial. So just to wrap up, hopefully this exercise was able to provide you with a framework for working with your own LiDAR data sets. I know it didn't go into great detail, but hopefully it gave you kind of a broad scale overlook of how you could start manipulating and analyzing some LiDAR data and hopefully incorporating it into your own analysis. And I hope also it gave you, for those of you that were new to ArcPro, a little bit of an introduction to this interface and how it differs and how it's similar. Hopefully it's not as daunting as it seemed previously if you hadn't made the switch from ArcMap yet. On the text instructions, there is a link to some LiDAR resources that Esri has put out, some help pages and things like that, but unfortunately they don't have any free courses currently in their training catalog. I think there are some courses listed that you can pay for or require a elevated license status, but those are on the text document. And thanks for tuning in. Hopefully this was helpful.